Hi, everybody. So in this video, we're going to talk about the phases of the cardiac cycle. So exactly what is happening in the cardiac cycle and kind of where are we moving, kind of what's happening in this whole process, okay? Now, in the previous video, we did talk about the SA node initiating a contraction in the atria, and then that contraction of the atria goes down through the bundle of His down through the bundle branches, and then finally out through the Purkinje fibers so that we can contract the atria. Now, importantly here, whenever we are starting this cardiac cycle, so we're starting this, everything is relaxed, okay? Atria are relaxed, ventricles are relaxed. With those atria and ventricles relaxed, this also allows us to have open atrioventricular valves. This basically lets blood that is flowing into the atria. Some of that blood is then going to drain out of the atria and into the ventricles, even while the atria are just relaxed. So we have a little bit more pressure in the atria than we do in the ventricles. It's basically, imagine like a cup with a hole in the bottom. So even if you have a cup with a hole in the bottom, you can still pour enough water into that cup where even if water's coming out the bottom, that the cup is still going to fill, okay? So that's basically what's happening here in this first step. Now, because there's no pressure from below, so because the ventricle pressure is fairly low, our semilunar valves, so in the pulmonary trunk and in the aorta, are closed, okay? So any relaxed blood is just gonna kind of be sitting in those little cusps there and not draining back into the heart. So we're not moving blood backwards, okay? Now, that is us kind of just waiting for everything to kind of fill. All right, particularly in this case, we are really waiting for the atria to fill while we're also filling the ventricles. All right, now the next step is that we are going to contract the atria. So we're going to contract at the top of the heart. So when we contract at the top of the heart, that's going to push the blood from that cup that we just had, and we're just kind of dumping those out. So we're kind of squeezing all of that blood in those cups out into the ventricles. Now, once we're in the ventricles, once the ventricles are filled, we're then going to move to our next step, which is going to be a contraction of the ventricles. Now here it's calling it an isovolumic, okay? Now, or volumic. What this really means is that we are having the same amount of volume in both the right and the left ventricles. That's very important that we have the same volume in both. If not, this would lead to swelling of one side or the other. Or swelling in particular places. We want to make sure that we're moving the same amount of blood through. Now, the difference is, you can see that this left ventricle is much thicker than the right. Well, the difference is that the right-hand side is only having to push up into the lungs. That's not very far away. That system isn't very big. So because of that, we don't need as much force, okay? So we don't need as much force. We don't need to contract with as much pressure. However, we still need to move the same volume. Okay. Now, the left side, this one's having to push everywhere with that same amount of volume. So that means it's going to have much, much tougher walls. Okay. Now, at this point, our signal has now crossed down through this Purkinje fiber, or crossed through the bundle of His, through the bundle branches, and now it's finally into the Purkinje fibers. So now we're telling all of these muscles to contract hard. So just wham, press this blood out as fast as we can. Now, when this happens, it's going to take those cusps that are pointing down towards the ventricles. Well, that little bit of back pressure here pushing against those valves is going to cause those valves to slam shut. This is actually what you hear as the dub in a heart sound, is these valves slamming shut. But if you look at the direction of the valves here, of the semilunar valves, you can see that we're pushing towards the opening here rather than pushing against the opening. So like if these are doors, we're kind of pushing in the direction that the doors will open now, okay? Rather than pushing against them in the direction that they'll close. So this is going to force, once we contract and we contract with enough pressure, we will then eject some of that blood through the semilunar valves, okay? So our next step is ventricular ejection. So we contract, getting enough pressure, and once we get enough pressure, that causes the atrioventricular valves to close, and then we actually eject the fluid through our semilunar valves, both our aortic and pulmonary semilunar valves. So those will push out, okay? Then we'll have our isovolumic relaxation occur. So we relax, but we're going to relax them and open them up to the same amount of volume, okay? So importantly here, we are making sure that we eject the same amount of volume and that we pull in the same amount of volume. This is going to help us make sure that once again, we're avoiding swelling in places. We're avoiding that edema, okay? By making sure that we're only moving the same amount of fluid around all the time. This kind of helps us equalize pressures and things like that everywhere, okay? Now, like I said before, equal amounts of blood are pushed by left and right sides of the heart. The left heart must pump things much further, so it must be stronger, thus have thicker stuff. And we do this to make sure that we avoid swelling. So if you have any questions about our processes of the cardiac cycle or anything like that, please just let me know. Thanks. See you next video. Bye.